Welcome to Fluid Coding and AI. Qwen 3.59b is a small, open-weight model with a big promise, multimodal input, long context, local deployment, and agent-style coding. The useful question is where that promise survives contact with real developer work. The wrong first question is whether this replaces much larger models. A better question is practical. What can it do well enough that you would run it locally, cheaply, or privately? By the end, the answer is not hype and it is not dismissal. It is a boundary map for where Qwen 3.59b fits. The official Hugging Face page identifies Qwen/Qwen 3.59b as a post-trained Qwen model in Transformers format. It is listed as image text-to-text, conversational, soft-tensors-based, and Apache 2.0 licensed. That matters because the pitch is not just another chat model. The public packaging points toward a model that people can serve, fine-tune around, and deploy across several open tooling paths. The headline capability is the surface area. Qwen's examples show text, image, and video input through an OpenAI-compatible chat completion-style API. The model card also gives SGLang and VLLM examples with a 262,144 token maximum context, plus reasoning parser settings, tool call parser settings, and speculative generation options. For a 9B model, that is a serious local assistant pitch. Qwen 3.5 also changes the control story. The model card says it thinks by default and it does not officially support the older Qwen 3/think and /nothing soft switch. Direct responses require API or template configuration, such as disabling thinking in chat template settings. That is useful for reasoning, but it can also add latency, verbosity, and awkward behavior if the runtime does not expose clean controls. The same model name can mean different practical experiences. Hugging Face has the source model. LM Studio community hosts GGUF files, including Q4KM at 5.63 GB, Q6K at 7.36 GB, Q80 at 9.53 GB, and a separate multimodal projector file. Together, AI lists a hosted endpoint with text, image, and video input, JSON mode, function calling, and serverless or dedicated deployment. The vendor-reported numbers are strong, but they should stay labeled as vendor-reported. Together's page lists Qwen 3.59b with scores including 65.6 on Live Code Bench, version 6, 66.1 on BFCL version 4, 70.1 on MMMU, Pro, 78.9 on MathVision, and 84.5 on Video MME. Those results make the model look unusually capable for its size, but they are not the same as proof for every runtime. Our local benchmark gives a narrower and less flattering signal. In one LM Studio run of local LLMBench coding cases for Qwen/Qwen 3.59b, the model scored 800 out of 2100, or 38.10%. It fully passed two easy cases, a date range validator and a fast API health and echo service. It did not fully pass any medium hard or very hard case. That does not prove the model is bad. It proves the workload boundary matters. The failed and partial cases included API services, setting systems, job queues, permissions, pricing logic, schedulers, webhooks, schema migration, secure file handling, and multi-step orchestration. In other words, the model can look useful in chat and small tasks, then struggle when the work needs state, constraints, tests, and follow-through. The context story also needs discipline. Qwen says the model natively supports up to 262,144 tokens, and that row PE scaling techniques such as yarn can extend context beyond that. The same guidance warns that static yarn can hurt shorter text performance if it is enabled unnecessarily, and it recommends lowering context length when out-of-memory errors appear. Long context is a tool, not free memory. The practical verdict is that Qwen 3.59b is exciting because it moves a lot of capability into a small deployable package. It belongs in the local worker lane, drafts, triage, document and screenshot understanding, small code changes, routing, and low-risk automation with tests around it. It should not be treated as proof that a 9B local model can replace stronger coding systems for high-stakes refactors or long autonomous projects. If you want more grounded AI model breakdowns like this, like the video and subscribe to Fluid Coding and AI. The small model space is moving fast, and the useful question stays the same: what actually works when developers put it under pressure?